Hey guys, this is Ms. Clark going over On Your Own Practice for 2.02 Reasoning Part 1. So we are going to use inductive reasoning for what is the most reasonable conjecture for the next number in the pattern. So inductive means we're going to observe and make a guess. So we go from, how can we get from 3 to 9? Well, 3 times 3 is 9. And then we add 1, and that gives us 10. Let's see if that works for the next group. 10 times 3 is 30, plus 1 is 31. 31 times 3 is 93, plus 1 is 94. So that means we have to do 94 times 3, which is 282. Alright, so these I like to use my snip where I can draw a picture. Alright, so we're going to go to the 8th figure. So let's look here. Alright, so there's 4 triangles in the first figure. 1, 2, 3, 4, 5, 6 triangles in the second figure. 1, 2, 3, 4, 5, 6, 7, 8 in the third. So it's going up by 2. So 4 has 10, 5 has 12, 6 has 14, 7 has 16, 8 has 18. So we're going to try 18, see if that works. And there's our explanation. Alright, now we have used inductive reasoning. What number most reasonable conjecture for the next number in the pattern? Alright, so what is happening? 27 to 23. 27 minus 23 is 4. And 23 minus 19 is 4. 19 minus 15 is 4. So if I subtract 4 from 15, I get 11. Let's try that. Good deal. Alright, given that A is an acute angle and B is an obtuse angle, Francesca conjectured that A and B are supplementary. Supplementary means add up to 180 degrees. So which statement is a counterexample? So we need 2 angles that are acute and obtuse, but do not add up to 180 degrees. Alright, so this one is not acute, so that can't be it. A is acute here. 20 plus 160 makes 180. That doesn't disprove that is supplementary. 110 is not acute, so that can't be it. But 30 is acute, and 30 plus 100 is only 130. That is not supplementary. So that disproves her conjecture. Counterexamples it. Alright, we're going to use inductive reasoning, which is observation, to what is the most reasonable conjecture for the next figure in the pattern. So, like I said, I like to draw on these. It helps me. So let's take a look at what's going on. This first figure is an octagon, which is 8. And it has 1, 2, 3, 4, 5, 6, 7 dots. This next figure is a heptagon with 7 sides, and it has 6 dots. Then we have a hexagon, which has 6 sides, that has 5 dots. And then we have a pentagon, which has 5 sides and 4 dots. We have a square, which has 4 sides and 3 dots. So the next figure would have to have 3 sides. That's a triangle. And would have to have 2 dots in it. Let's see if that works. Triangle with 2 dots. All right. Which is an example of inductive reasoning. So remember, this is something that can be when you find from observing. Jeremy can buy a car if it's priced $8,000 or less. The salesperson shows him $7,195 car. Jeremy can buy the car. That's true, but did we really observe that? The first 4 cars that Jeremy sees in the lot, I like that word sees, priced above his budget. Therefore, he expects all cars in the lot to be above his budget. So he's looking at those things. I feel like that one's it. All cars are vehicles. All vehicles have wheels. Therefore, all cars have wheels. That's more deductive. And this is more deductive too. He makes $100 a week for 80 weeks. He has $8,000. Let's see if we got it right. From observations. All right. Ooh. Which answer is an example of inductive reasoning? Observations again. All the stores in Misuko's neighborhood are open by 10 a.m. Molly's Market is a store in Misuko's neighborhood. Molly's Market is open by 10 a.m. Every time Misuko sees her grandmother at the grocery store, her grandmother is wearing a red jacket. Misuko concludes her grandmother always wears her red jacket to the grocery store. So that's something she's seeing. So I kind of feel like that one's it. Store is open 24 hours a day, 7 days a week. The store never closes. That seems very deductive. Misuko goes to the store. She buys gum. If she buys gum, then she buys a lollipop for her brother. So if she goes to the store, she buys a lollipop for her brother. More deductive. And there we go. Based on our observations. All right, here's another pattern. I like to draw these. All right, so we're looking for the 5th number in the pattern. So, first one has 1. The second one has 3. The third one has 1, 2, 3, 4, 5, 6. So this added 2, this added 3. So it's adding the number. So that means it'll add 4. So that'll be 10. So the 5th in the pattern would add 5 to that total, and that would give us 15. Let's try that. Good deal. N is an even integer. Chaz conjectures that n is divisible by 4, which is a counter example, which disproves his conjecture. So we need to find an even number. So it can't be this one. That's not an even number. 20 is divisible by 4. 32 is divisible by 4. But 14 is only divisible by 2 and 7. And that is on your own. Reasoning part 1.